of the parties which took place almost a year ago in Spain. Carlos Duarte has established himself as one of the leading global authorities on the ecology of seagrass meadows and coastal ecosystems. He is the most versatile aquatic ecologist of his generation. And many of his synthesis papers set up a stage for the field. For example, his work initiated the discussion on the heterotrophic nature of oligotrophic systems and identified the role of hypoxia thresholds for marine biodiversity. We are extremely happy to have him today with us. Before we start, I would like to note that you may leave your questions in the chat box in case you have any, and we will try to address them by the end of our seminar today. With that note, I would like to finish my introduction. Please, Professor Carlos, the Zoom platform is yours.
Thank you very much, Natalia, and thank you, Iman, and congratulations to the Students for Sustainability for the initiative. And again, thank you for the invitation to come and join you today. So I will share my screen to start my presentation here, I think. So I hope you can all see my slide. Yes?
Yes.
Okay, I assume so. So let me find the, yeah, here. Okay, so I'm going to talk today about carbon in a circular carbon economy, which is an emerging topic for research and discussion in Kingdom and also at KAUST. KAUST has a circular carbon initiative that I'm not going to describe because I see that in 2 weeks you have one of the leaders of the initiative, Professor Jorge Gascon, as a speaker. So he will surely report on that initiative with far more knowledge than I would be able to do. But I would like to share with you kind of a personal journey about finding a path to be able to tackle the difficult problem of climate change through a perspective of how carbon can be managed in a circular economy. And this is all inspired by learning from nature. So I'd like to start from the very beginning. So that's when our planet was formed. And then before the Earth was populated with living organisms, the atmosphere of the planet and the conditions in the planet were very different from those today. There was basically no oxygen. Carbon dioxide was about 20 times higher in the atmosphere than it is today. And as a consequence, the surface temperature was about 50 degrees compared to 16 degrees at present. So this transformation of the planet Earth into an atmosphere with much less carbon dioxide, with about 20%, 21% of oxygen, and a much lower temperature that is conducive to life and the growth of life in the planet, was actually a result of life. And it was a result of the effects of metabolism of organisms on carbon dioxide and oxygen that are linked through photosynthesis and respiration. So it was life that transformed the planet from something that it was in between current Earth and Venus, past Earth and Venus, into something that is inhabitable today. So in fact, climatic stability in the present Earth system, and I use present in a geological sense, so that will be about the last million years, is achieved by a closed loop circular carbon economy, which we call the global carbon cycle. And basically every year, biology takes up about 780 gigatons of carbon dioxide from the atmosphere through photosynthesis, which supports growth, reproduction, and also respiration of organisms to perform all of the functions that organisms require for the life cycles. And then the energy is eventually released through respiration that not only releases the energy to support all of those biological processes, but also returns carbon dioxide. And this global respiratory processes return 780 gigatons of carbon dioxide back to the atmosphere. So this is a loop that we call the carbon cycle, and is the fundamental engine of life, and its functioning depends on the abundance of life, which is the natural capital that drives this global carbon cycle. There are a lot of nuances on the global carbon cycle, so this is a very parsimonious, minimalistic cartoon of how it works, but basically it's a balance between carbon removal and return to the atmosphere, which will become important in terms of understanding our own role of humans in the biosphere. So the coupled production respiratory loop of the carbon cycle, which is really the metabolism of the biosphere, is an essential component of what we might call a supra-organismal homeostatic system, which is Gaia, the biosphere, that confers climatic stability to the Earth system. So if we look at records of carbon dioxide over the last 800,000 years, it has been relatively uniform, ranging between 180 and about 300 ppm. And those oscillations, which have to do with events that are alien to life, like volcanic events, asteroids maybe hitting the Earth and generating dust, and also changes in the position of the Earth relative to the Sun. So these small oscillations are responsible for changes in global temperature, but this range is very, very small. So this stability of the atmospheric composition and therefore climate is achieved through a tight coupling between photosynthesis and respiration. And in fact, the offset between those two numbers is so small that it's impossible to resolve experimentally. So we need to use models and constraints to calculate what is the difference between global photosynthesis and global respiration. And we calculate that this offset is of the order of 0.1%. So it's a very small number, and these two very large fluxes are in very good balance. And in fact, when production exceeds respiration over an extended period of time, then the biosphere accumulates carbon, and carbon accumulated over 6 million years ago and earlier is actually the oil that we have been using to power our economies, right? So it's an outcome of this small balance accumulated over time. So a simple account of how humans have affected the climate system based on this simple representation is that we can think of fossil fuel burning as exosomatic respiration. So early on, humans learn how to release energy from biomass, from organic materials through combustion processes. First, we invented fire, and then we were heating ourselves and cooking with that fire. But after the Industrial Revolution, then we learned to use massive deposits of oil as a source of power and energy for our economies. So this fossil fuel burning acts exactly as a respiratory process, only that it happens in an engine outside our cells and bodies. So it oxidizes organic matter to release energy and carbon dioxide and consumes oxygen. So it's exactly the same as a respiratory process, also releasing energy, but it just happens outside our bodies, and therefore it's not constrained to our biology, and we can scale it up. So as we have learned how to conduct exosomatic respiration, therefore adding to respiration by organisms into generating a flux of carbon dioxide to the atmosphere, we have also depleted forests on land and the oceans. That means we have reduced the global production, and as a consequence, we have upset the balance further. So about 18% of the accumulated greenhouse gases in the atmosphere derive from destruction of ecosystems and alterations to ecosystems or poor management of agroecosystems. And this amount has been 24% over the last decade. So very often we equate climate change to fossil fuel burning, and we forget about the contribution of what is called land use change, but it's really a much broader set of of processes that lead to emissions of greenhouse gases and carbon dioxide from our impact on ecosystems. So we have disrupted the closed carbon cycle by both depleting carbon and reducing production, and also enhancing exosomatic respiration, that is enhancing the flux of carbon dioxide and other greenhouse gases to the atmosphere. So the consequence is rising atmospheric carbon dioxide and other greenhouse gases concentrations in the atmosphere, leading to global warming and associated impacts. And these two graphs show updated values of carbon dioxide at Mauna Loa Observatory in Hawaii, that holds the longest record of carbon dioxide in the atmosphere. And the last data point is from September this year. So you can see that we have already exceeded 410 ppm of carbon dioxide in the atmosphere, and then we continue to go upwards. And then you can see a parallel curve of increase in the thermal anomaly, so the increase in temperature relative to a long-term average across the whole planet, that is parallel to the rise in carbon dioxide. And we are en route, under present emission pathways, we are en route to continue to increase mean global temperature above pre-industrial levels by about 2.6 to 4.5 degrees over the current century. Compare, and even if we look at what will be the pathway if nations comply and deliver all of their commitments under the Paris Agreement, that still is 3.2 degrees, whereas the Paris Agreement aims at capping the warming of the planet to a maximum of 2 degrees, and if possible, keep it within 1.5 degrees. So we're really still far away from meeting that goal. So this year, I published a paper that might be of interest to Students for Sustainability, because it was a survey of the perceptions of Saudi citizens on marine environmental issues. But one of the questions we asked them, which is reflected in this slide, is we asked them to freely identify what, in their opinion, were the major challenges and the major issues of humanity was facing. And you can see that climate change was second, together with poverty, lack of food and drinking water, and war and conflicts were the first issue. But climate change is prominently up in the perceptions of global challenges by Saudi citizens. And you can see a spread of infection diseases down there, but the survey was conducted in 2019. So maybe infection diseases would have climbed a number of positions today. And the Saudi citizens that were surveyed also ascertained that most of the environmental issues, particularly climate change, were mostly due to human activity or entirely due to human activity. So about 92% of the Saudi citizens that were interviewed identified human activity being either partially or entirely responsible for climate change and environmental issues. And also the Saudi citizens that were interviewed then also reported on what are the actions that are willing to take to be able to contribute to solve these problems. And within those, 73% thought that reducing energy consumption in their households and in their whole community was an important step towards improving their the situation of climate change and mitigating climate change. And they also identified the consumption of sustainable energy as something that they would be inclined to do, but only 16% of them were looking at sustainable energy as something that they will be willing to engage with. And there was also some other questions about single-use plastics that we're going to touch upon also here because it's relevant, and also the consumption of local food products, where 45% would favor local food products versus products imported from elsewhere. And also they found environmental friendly transportation was not one of the actions that they will favor. possibly because in many cities and areas still in the kingdom, public transportation is not sufficiently developed to be an option. So in any way, I think that it's important that Saudi citizens also recognize climate change as one of the main challenges of our times and are willing to take a number of actions to respond to that challenge. And I would like to then dedicate the rest of the time that I have with you to talk about how can we seek inspiration from how nature manages carbon to be able to tackle the climate change problem. And I will start by arguing that to be able to manage this problem, society needs to embed its processes on a circular carbon economy, because that's the way that nature manages carbon. And nature has a very good track record of about 3,500 million years of R&D. And this R&D has led to this mechanism of a balanced carbon cycle and a circular carbon economy as the process that has delivered a climatic stability over long time spans. So taking inspiration from how nature manages carbon and how nature works is not unique to trying to find solutions for climate change, but I would like to introduce a colleague and a friend of mine, Bill McDonough, who's an architect from the US that has been thinking for a long time on how to reproduce the way nature operates in our own human enterprises. So in 1970s, when he was freshly graduated from architecture school, then he dreamed he will build buildings that will work like trees. So these buildings will produce more energy that they consume, will process their own waste to grow food, and also produce clean water. And in fact, he designed the first building that worked like a tree in 1972. And eventually he received the Medal of the President of the US for his contribution to establishing the framework for sustainability. So Students for Sustainability, here you have the father of the concept of sustainability. And I hope that you will find an opportunity to also welcome him as a speaker to the seminar sometime soon. So he's actually well known for being a positive thinker, and to some extent he's been thought to be an utopian, but his utopies are already delivering important outcomes. So one of his contributions was that in 2002, he co-authored a book with Michael Braungart called Cradle to Cradle, where the main tenet of the book is that everything should be a resource for something else. So in nature, the waste of one system is the food for another. And therefore, they pledged that everything can be designed to be disassembled and safely returned to the soil as biological nutrients, or either reutilized as high quality materials for new products, which become technical nutrients, driving our industrial processes without generating contamination. So this concept of cradle to cradle has these two engines: biological nutrients on a circular economy and technical nutrients on a circular economy. And just 2 weeks ago, Amazon announced a very large climate pledge. So Amazon is already created a very large multi-billion-dollar fund to contribute to solving the climate change problem. But they also pledged that they're going to certify their products for sustainability, and they have adopted a Bill McDonough's Cradle to Cradle certification system. So Bill is a partner to Amazon in their sustainability strategy and the delivery of that. But the concept of cradle to cradle is then the inspiration for the concept of the circular economy. So in a linear economy, you take, you make, you use, you dispose, and eventually you pollute. But in a circular economy, you make, you use, you reuse, you remake, you recycle, and you continue to reuse the materials in a hierarchy of R's, which are reduce, reuse, and recycle the materials that are used in different processes in society. This is directly inspired from Cradle to Cradle. So Bill McDonough is also the father to the circular economy framework, and recognized as such. So we can apply that framework to solve the problem of plastics and manage plastic bottles by either mechanically or chemically recycling them and then producing again bottles, or producing other materials or feedstocks to produce other products, or eventually even if the material is contaminated in any way and is hazardous, like for instance, personal equipment made of plastic under COVID shouldn't be reused because it needs to be incinerated to 1,000 degrees to be safe, then you can generate energy from these materials. But you can also design cars. And in fact, Bill collaborated with an automobile maker to design a car that could be fully disassembled and every part of it could be recycled and reused. So you can also do cars, which are far more complex than a water bottle. And you can do buildings, which Bill has been doing since 1972, and he has done many, many green buildings across the world. But you can also design cities, and Bill has designed a city in China that will be a cradle-to-cradle city with a perfect circular economy that will not generate any waste nor require any input of energy or even food to function. So what about if we could also apply a circular economy to the planet? Can we do this at the planetary scale? So up to 2015, Bill was mostly busy working with buildings, architecture, also furniture, textiles, and other materials. But then he thought, because he uses carbon a lot in his designs and materials, he was a bit upset that carbon was being demonized, and wrote a commentary in Nature published in 2016 called "Carbon is Not the Enemy." And he pledged that we need to design with the natural cycle in mind to ensure that carbon ends up on the right place. So it's not a problem with carbon per se, it's a matter of us not being able to deliver sound stewardship for the carbon that we are using. And in that article, he introduced a new language of carbon, where he introduced classified carbon into living carbon, which is the carbon that supports the flows of materials in living systems, in ecosystems, agriculture, and so on. And living carbon is positive and needs to be optimized. Then he defined durable carbon. That is the carbon that we use in building materials and that we keep in technological cycles. And that material, while kept in technological cycles, is also positive because it helps us drive our economies. And then he aims at most of this carbon being working durable carbon. So the carbon is lasting a long time in the technology cycles. And finally, he defined fugitive carbon, which is carbon that has escaped from both technological and biological cycles, and now it's in the atmosphere causing trouble. So that fugitive carbon is negative carbon, and it's the one that needs to be targeted. So, but there's nothing inherently wrong about carbon if we're able to keep durable carbon within technology cycles and then expand living carbon to be able to maintain biological processes. So I actually met Bill for the first time in the World Economic Forum in Davos in 2018. So Bill is the gentleman in the left holding the microphone, and I'm the person in the right. So I was presenting along with His Excellency Dr. Fahad Tumsi the new vision for ocean stewardship and conservation under Vision 2030. And then we were hosted by Bill in the Ice House, which is a sustainable building he built in Davos, actually in partnership with SABIC. So we met there, and then we immediately, we actually discussed this language of carbon at that meeting, and we really connected. So, we have then followed a path of convergence where my work on global carbon cycling in the biosphere and carbon sequestration by living systems, then resonated strongly with his ideas of cradle to cradle and the way we can manage carbon and materials in a circular economy to generate wealth and prosperity while avoiding environmental problems. So we have been working already for a number of years on this topic and merging geochemical sciences with design and architecture and sustainability science. And then last year in the COP25 in Madrid, then we had two events. One event that was maybe a 3-hour event was a dialogue between him and I around the circular economy of carbon, hosted by the BBVA Foundation. So it was part of the formal program of the COP25, and you can view it there. So I gave a talk about my views on how nature manages carbon, and then he took from there as to how we could learn from nature in how we should manage carbon ourselves. And we also organized an event on the circular carbon economy that was organized by the Ministry of Energy with 3 speakers from KAUST. So Jorge Gascon, Professor Jorge Gascon is at the left. Professor Susana Agusti is next to me on the right. And then we had Dr. Tijani from Aramco also as a speaker talking about carbon capture technologies, and Bill McDonough also talking about circular economies and how we could embed carbon in circular economies. And in COP25, we started working on a new framework to tackle the problem of climate change, which we are looking to publish in Science, and I think it's scheduled to come out on November 19. So we are now working hectically to improve the paper so that it will be released by that time with the editors of Nature. And this year, as Natalia indicated during the introduction, then Bill and I also gave the opening talks in tandem because they were again related. So I spoke about how nature manages carbon, and then Bill followed as to how we could kind of mimic that process in designing circular carbon economies. So that was the start of the first G20 Climate Stewardship Workshop in Riyadh. And then both Bill and I have continued to be involved in the process since. And KAUST has in fact had a very large contribution to this particular climate stewardship work, group, with many KAUST professors contributing to the different discussions, also in the energy group and in many other streams of G20. So I would like to thank KAUST for the support and the opportunity that it gave me and other colleagues to participate in the G20 in support of the Kingdom and the whole G20 partnership. So basically, if we go back to climate change and we read the text of the Paris Agreement, which is the global framework to address climate change, then the Paris Agreement in the Article 4 pledges to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of the 21st century. So really, the Paris Agreement already pledges to be able to deliver a circular carbon economy embedded in the working of the biosphere, because that's exactly how the biosphere manages carbon. So I found when I read the Paris Agreement, I was very inspired by this particular article, because it really brings the human enterprise in a coherent framework with how nature works. And we are just one more species in the planet, sharing the planet with many, many millions of species. And there is no reason why we should believe that we are not bounded by the laws of nature. So I think we should better come to grasp with the laws of nature and achieve a circular economy of carbon, as implicitly stated in the Article 4 of the Paris Agreement. So the first step for me, because I'm a marine ecologist and an ecologist, and so therefore I do not develop technologies for carbon removal and things like that, but I do work with ecosystems, is to rebuild nature. And this is important because nature is the new capital, because we have decimated the abundance of life, both on land, on the oceans, and this capital is essential for our human well-being. And carbon is the building currency of life. So certainly carbon cannot be the enemy. And this currency of life or capital is invested in a diverse and balanced portfolio that we call living carbon, which is a carbon distributed across millions of species, from microbes to the largest whales, and also carbon that is safely stored in reserves in organic carbon that are accumulated in soils, both on land and the ocean, and also in geological reservoirs. So that there's a storage of carbon also in the biosphere and the planet. So 50% of the natural capital, that is the living carbon, has actually been lost throughout the 20th century. And recovering the 50% lost natural capital by 2050 is a global challenge. It will require that we grow the abundance of life in land and oceans by 2.4% per year. But this is doable, and I will show you some evidence that this is doable. So this is about rebuilding the green and blue natural capital, so the forests and ecosystems on land, and then the abundance of life and marine forests in the ocean. It is about reversing large-scale land and ocean deforestation through large-scale afforestation programs, and also efforts to recover the abundance of life, particularly large marine animals like whales. And it will help mitigate climate change, while it will also add adaptive capacity, resilience, and multiple benefits. So this is actually a diagram that Bill McDonough and I have been working on, and that was presented at the G20 in March. So we continue to work on this, and an advanced version of this will be published in this forthcoming paper in Nature. So what you can see in this diagram, and it kind of resembles the cradle to cradle, because again, we have a technological cycle in blue, which manages durable carbon. And then we have a biological cycle in green, which manages living carbon, right? So this is similar to the cradle to cradle. So it's in fact an offspring inspired by cradle to cradle, but then it requires energy to function. And that energy can come from hydrocarbon sources, and it can come from non-carbon sources that include all renewable energies and geothermal energy, and eventually hydrogen that might be generated as a carrier from these non-carbon energy sources, but also can be generated from hydrocarbon sources. So you can see the 3 R's that are genetic to the circular economy framework: reduce, which in the framework of the circular carbon economy to mitigate climate change involve avoiding the emission and production of greenhouse gases. So we need to reduce the production of greenhouse gases, but then we have reuse and recycle. So we have the 3 R's of the circular economy framework, but we have added a number of additional R's. So we have added remove, we have added recover, and we have added regenerate. So now there are 6 R's that are required to achieve a circular carbon economy, and also undo the problems that we generated by operating during over a century in an imbalance with the way nature works. So I'm going to focus on remove. So you can see remove in the sides of the image. And remove is about taking carbon from the atmosphere to either put it into living organisms and soils, or else put it into carbon reservoirs. But some of the carbon that is removed from the atmosphere can be recovered either to biological cycles or to technological cycles, and then be reused and recycled. So some of the ambition is to recover as much carbon that is removed from the atmosphere as possible into the economy, both the living economy of the biosphere and the economy of the technosphere and industrial processes that we use to fabricate elements and also power both economies, both the biological economy and the technological economy. And I will talk about regenerate also as well, but let me focus a bit on remove, and let me tell you a bit about remove on the left side of the diagram. So if you look at remove on the blue component, this involves technological fixes to remove carbon dioxide that is already fugitive in the atmosphere and creating problems like climate warming and global warming, but also when dissolved and equilibrated in seawater, ocean acidification. So we can remove some of that carbon with technological fixes, but we can also remove that carbon with nature-based solutions. That means to decarbonize the atmosphere and therefore remove fugitive carbon, to recarbonize the biosphere. And there we have another R. So you might have heard a lot many world leaders talk about the need to decarbonize the economy. And Bill and I argue that the problem of climate change is not about decarbonizing the economy, because we actually need carbon moving in the economy, both in the living carbon economy and the durable carbon technological economy. The problem is about decarbonizing the atmosphere, not the economy. And one pathway to decarbonize the atmosphere is to do so by recarbonizing the biosphere and therefore increasing the abundance of living carbon, which is a good thing to do. So recarbonizing the biosphere and nature-based solutions are about restoring the abundance of life on land and oceans. And in doing so, then taking some carbon dioxide that is in the atmosphere and putting it back into living organisms. So in this year, in April, I led, along with Professor Susana Agusti, also from KAUST, a paper that was published in Nature called Rebuilding Marine Life, where we reviewed the evidence of our capacity to, once we remove pressures on the marine environment, have the organisms that were lost recover. And we pledged, based on a review of the evidence, that we could rebuild the abundance of life in the oceans by 2050, within one human generation. And we put forward a strategy to achieve that, right? But keep in mind that then, if we are going to recover the half of the global abundance of marine life that we lost, that actually involves removing carbon dioxide from the atmosphere, so decarbonizing the atmosphere and recovering that carbon back into an abundant ocean full of life and organisms that perform and support a lot of processes, many of which benefit humankind. So nature-based solutions is a cost-effective strategy because it value adds. So when you remove carbon dioxide from the atmosphere with technology fixes, which we will need to do and we will need to do at scale, then there's a cost associated, but there's really no value adding to that. But when you remove that carbon with nature-based solutions, you generate a lot of benefits beyond contributing to climate action. For instance, you contribute to alleviate poverty, you contributed to remove hunger, to generate decent growth and support economic growth, to generate sustainable cities and communities, to also promote a responsible consumption, clean water, restore the abundance of life in oceans and life. So there are many, many goals of sustainable development that are served by nature-based solutions compared to the strategy of removal based only on technology solution. So then it is evident that most nations around the world are now looking to maximize their portfolio of nature-based solutions. And we are thinking outside the box to try to come up with new ways of delivering nature-based solutions, that is, decarbonize the atmosphere to recarbonize the biosphere. So most of the discussion, the conversation around nature-based solutions has been about managing forests and agroecosystems, but in fact we are starting to look beyond forests. And this paper, the contribution of whales to nature solutions to climate change, was actually not produced by ecologists, but was produced by one of the chief economists of the International Monetary Fund, Ralph Chamy, who calculated the value of a whale and calculated how much of that value actually comes from the carbon removal capacity of whales. And they came to a calculation that if we were to rebuild the abundance of great whales, which are depleted to 20% of their historical abundance, so if we're able to multiply this by 5, then that alone will be able to remove 0.8 petagrams of carbon per year, which is about 8 to 10% of the global removal of greenhouse gas emissions that we need to do to achieve climate stability. So that 10% is actually a lot, only by allowing whales to rebound to the formal abundance. And just to give you a hint that this is actually possible, by year 1978, there were only an estimated 200 humpback whales left in the ocean. And that led to a moratorium of hunting by the International Whale Commission. And by today, there are already more than 60,000 humpback whales in the ocean. And each of these, that population alone, just in the carbon binded in their bodies, is about 50,000 tons of carbon, or about 160,000 tons of carbon dioxide that used to be carbon in the atmosphere and now is carbon in whales, which is a lot nicer to look at than carbon dioxide in the atmosphere. The same, we can give an example for northern elephant seals, which had been hunted down to only 20 animals by 1900 in the Pacific coast of the US because of a search for their oil and fur. And they seem to be earmarked for extinction, but a conservation program allowed them to rebound. And by today, there's about 250,000 of these animals basking in the shores of California and Oregon and Mexico. And that's about, again, 25,000 tons of carbon that used to be in the form of carbon dioxide in the atmosphere that now are present as northern seals basking in the beaches, which again is much nicer to look at. Many of you might not be aware, but there's a connection between whale hunting and the loss of whales in the ocean and climate change, because before we moved to oil, we actually hunted whales to burn them. So we hunted whales for their oil. And this is a sample, this is an image of a sample of oil. And we use this oil to light the streets of cities in Europe and North America and other nations before we use gas and oil and fossil fuel oil. So actually we've been burning whales for about 150 years. And that is the reason why we lost 80% of the stocks of whales in the ocean. It was not for their meat, it was for their oil. And the same for northern elephant seals, and then other species that actually, unfortunately, were driven to extinction and hunted to extinction, so we cannot rebound them. So whale carbon has been actually being seen in the atmosphere as carbon dioxide. And just imagine that it would be within our reach that within 30 years, we could take that carbon dioxide in the atmosphere and enjoy it again in the form of whale carbon. But whale carbon is only one component of carbon sequestration. And there's many, many ways in which large marine animals contribute to carbon sequestration. So there's something called the whale pump that is represented here, which is that many whales go into the deep sea to feed, and then they come up to the surface to breed, and there they release the carbon and nutrients, and they fertilize the ocean and keep the ocean fertilized and productive. There's also something called the ladder of migration of marine animals, through which they feed in the upper layers and they go deep, and then they excrete at depth, and therefore they move carbon from the upper layers of the ocean to the deep ocean where it gets sequestered. And we have a paper in press in Nature Communications that calculate that flux to be about 2 petagrams of carbon, which will double the contribution of passive sedimentary fluxes and also a equilibration of carbon dioxide between seawater and the atmosphere. So again, if we rebuild the marine food web, we can catalyze and energize all of these processes. So this is about regenerate. So there's one more R, which is to regenerate the ocean, regenerate the ecosystems, and that regeneration will bring about a more vibrant biosphere that will be able to sequester more carbon through a range of processes. And in fact, I'm focusing on this, but I have already done a lot of research along with many colleagues in the role of vegetated habitats in the shorelines, mangroves, seagrasses, and salt marshes in sequestering carbon. And those are already proven technologies to also remove carbon dioxide from the atmosphere and increase carbon sequestration by rebuilding the forests of the ocean, of mangroves, seagrasses, and salt marshes. So every year we learn new ways in which we can deploy nature-based solutions that contribute to mitigate climate change. So the first option was based on conserving tropical forests. So in 2005, the RED Plus program, which was a program to mitigate climate change through the conservation of tropical forests, was established. That led to something called the Billion Tree Campaign. There was a pledge to increase the abundance of forests by 1 billion trees. And in 2009, along with some colleagues in UN agencies, then I put forward the concept of blue carbon, which is how we can also mitigate climate change by restoring the abundance of mangroves, seagrasses, and salt marshes in the ocean. And then in 2010, there was a mitigation of climate change program in agriculture based on managing carbon in soils and agriculture to increase carbon sequestration. Now, in 2017, I published a paper proposing seaweed farming and also a component of nature-based solutions to mitigate climate change. And this is gaining a lot of momentum. And there's a rise and a growth of interest in seaweed farming for climate change mitigation. And I'm now leading a global program to calculate the contribution of seaweed farming to carbon removal, and also developing a voluntary carbon credit system for people to be able to invest in carbon that is being sequestered with seaweed farming. And this year, the World Economic Forum then launched the Trillion Tree Campaign. So you can see that in only 15 years, the pledge has moved 1,000 times from 1 billion tree to 1 trillion tree. And there are discussions to how viable that is, but it is again one of the emerging options. And then in this year, then we have also proposed the effort to rebuild marine life as also a nature-based solution to mitigate climate change. So when we stack these solutions, the power of nature-based solutions is likely to reach about 25 to up to 30% of the global effort required to reduce greenhouse gas emissions and achieve the climate goals of the Paris Agreement. So I'm sure there are many more processes, and we're publishing a paper now led by Vincent Sadern. That was a former postdoc of mine at KAUST, but he's still working at KAUST, where we report a new mechanism through which mangroves can remove carbon dioxide, and that is through generating alkalinity by dissolving carbonates that are present in the soils, in the Red Sea and the Arabian Gulf. And that mechanism actually multiplies by 4 to 6 the carbon removal capacity of mangroves. So every day we're learning a new way in which we can deploy nature-based solutions to mitigate climate change. So we would like to organize a conference next year on pushing the boundaries for nature-based solutions and think about the box to come up with additional solutions. So the vision is to have not a circular carbon economy, because by now we have put enough carbon dioxide in the atmosphere that we will not like to maintain it as it is. So we need to have a positive carbon economy that takes carbon dioxide from the atmosphere and fits it back into both the technological cycles and the biosphere. So we need to rebuild natural capitals. We need to develop a circular carbon economy. And also we need to develop carbon dioxide capture technologies at scale to be able to deliver negative emissions as required. And each of those deliver a number of benefits in terms of environmental benefits, also mitigate climate change, of course, but they also generate new revenue streams and new activities of industrial activities and new sectors that might invigorate the economy and generate new sources of jobs and wealth. So that is the vision. And then I'm also interested in seeking inspiration from nature in processes that are a little bit hidden. Like, for instance, the slow process through which the Earth system also is able to balance greenhouse gases in the atmosphere, which is silicate weathering and carbonate dissolution that operate in the many thousands of years of time scales. So this is too slow for us to feel on time scales of decades, and therefore this process have not been considered much in terms of components of nature-based solutions to climate change mitigation. But we can actually drive inspiration from this process. And even if we look at the very modest oyster, which can be an unsung climate warrior, oysters actually take carbon dioxide that they respire, and then they're able to produce carbonate with this carbon dioxide. And they do that assisted by a highly effective protein. There's a carbon anhydrase, an enzyme that hydrates carbon dioxide and produces bicarbonate, and eventually captures this carbon dioxide into aragonite, which is the carbonate form of the oyster shells. So what about if we were able to learn from the oyster and harness the capacity of this carbonic anhydrase and be able to produce cement with carbon dioxide, and therefore on the one hand remove carbon dioxide from the atmosphere, and on the other hand also produce cement without generating emissions of carbon dioxide, because cement production today is an important source of carbon dioxide emissions to the atmosphere. So in fact, it's not only about oysters, and just here around KAUST, we have also some unlikely contributors to the solution. So this paper was just published a few weeks ago in the Journal of Carbon Dioxide Utilization, and it's about efficient sequestration of carbon dioxide into calcium carbonate using a novel carbonic anhydrase purified from camels. So even camels may also come to help us in finding solutions to climate change. And in fact, humans have the largest reservoir of carbonic anhydrase, which we use in our bodies to produce our bones. And also when we have excess carbon dioxide in our blood, then carbonic anhydrase is activated to remove that carbon dioxide, which otherwise will lower the pH and lead to acidosis and put it into bone. So if we are exposed to too much carbon dioxide, one of the consequences, as we are publishing now, is osteoporosis, right? So, but we do also have that capacity. It's not only camels and oysters. We humans have the largest pool of carbonic anhydrase in the biosphere because we have such huge biomass ourselves. So nature-inspired solutions can open a large portfolio of options. We can learn from how nature uses dead matter to support growth and fertility, how nature creates complexity and the redundancy to generate resilience. We also can learn how nature removes toxic materials, how it adapts to change, how biology cooperates across multiple levels in holobionts, so organisms that are consortium of multiple organisms, symbiosis, mutualism, and other cooperative processes. And we can also learn from how information is packaged, transferred, and improved in living systems. So it's an endless array of opportunities within nature for a rapid implementation of a circular carbon economy. So I would like to finish with two slides. One is just a reminder that the circular carbon economy is not only a framework to manage hydrocarbons or emissions and climate change, but it also can manage any carbon form. So for instance, this paper was published just a few months ago in Renewable and Sustainable Energy Reviews, and proposes a circular economy of plastics, which is very similar to you because it also has the 4 R's. So they have also other recover, to reduce, reuse, and recycle, which is a process of convergent thinking, and they need to add recover because in the same way that we have allowed carbon dioxide to escape into the atmosphere, creating trouble, then a lot of the plastic that has been produced since the 1950s is actually now loose in the environment, in the oceans, in soils, and we need to recover it to the economy as well. So that is another component of the circular carbon economy, which is plastics, and the two are linked because actually plastics, or most plastic polymers, are produced from hydrocarbons. So the system that we are designing for a circular carbon economy that Bill and I will be publishing should be able to accommodate any form of carbon. It's not prescriptive as to only being able to accommodate energy fluxes or greenhouse gases. It can accommodate any form of carbon. So the overarching principle is that we need to strive towards a net positive global carbon economy. A circular carbon economy alone is not enough, and we need a new narrative to be able to do that. So I'm very happy and honored and proud to work in the Kingdom of Saudi Arabia, because it is leading now the world in this strategy to address the climate problem. And this was first presented in October 31st, 2019 by His Royal Highness Prince Abdulaziz, Minister of Energy, that announced the circular carbon economy as a framework that the Kingdom would like to develop in-house, but also collaborate with others to be able to deploy it internationally. And since this first announcement in October, the Kingdom of Saudi Arabia, as the president of the G20, has also shared this concept with the G20 partners. And just a few weeks ago, in September 19, the Council of Energy Ministers of the G20 adopted a document that adopts the circular carbon economy as a framework that is very useful in addressing the climate challenge. And that is a major feat, and to the credit of His Royal Highness, because in the G20 there are very, very different sensitivities and perceptions and ways to understand the problem of climate change, but also how to respond to that. So, for instance, from the US, that, as you know, has pledged to remove itself from the Paris Agreement, to the EU and other nations that are really adamant that the only way forward is to reduce the use of fossil fuels. So everybody was able to find a home for their efforts within the circular carbon economy, and that has offered to the world a framework in which, rather than fight and fight with each other and have misunderstandings, we can actually collaborate to solve the problem. We can see now that, for instance, Saudi Aramco is developing their own circular carbon economy framework, and that comes from the webpage of Saudi Aramco. So they're considering the 4 R's to achieve a circular carbon economy within their operations, which are major, because I remind you that Saudi Aramco is the largest company in the world. Then also KAUST has developed also a framework for circular carbon economy with a strong focus on energy. And KAUST has developed a circular carbon economy initiative that is led by Professor Donald Bradley and Professor Jorge Gascon. And I believe Professor Jorge Gascon is scheduled to speak at this forum on 21st of October. So this presentation of mine serves as an introduction to the more exciting presentation that Jorge Gascon will provide. But all of this activity in Kingdom is actually framed within a national program of circular carbon economy. There is the world's first circular carbon program at a national scale, and one that has ambition also to have global influence. So that actually makes me very proud and happy to work at an institution in Kingdom and to have been able to collaborate with the leaders of that vision to, with my very small contribution, bring it to reality. So that is all that I wanted to share with you. I think this is the last slide, yes. So with this, I will stop, and I will be happy to take any questions. I see there's some things on the Q&A. So I might just go ahead and read it, but I can give the floor to the chair to manage the question period.
Thank you, Professor Carlos, for such truly insightful and inspirational presentation. It was very interesting, and we have a great interest from our audience. We had almost 100 people joined us at the peak. Should I then move to the question and answer session? How many minutes do you have to answer them? Like, can we take a few questions?
Yes, I can take. Okay. I can take as many as needed.
Okay, then We'll start with the first question of Professor Ted Patzek. He is here the director of Alien Naming Petroleum Engineering Research Center at KAUST. I will just read the question. Your narrative is calculated to soothe the fundamentally unsustainable human nature. Nature is a delicate balance of millions of interlocked cycles. Introduce a disbalance in one and suddenly you miss components coming from the supporting cycles. So, for example, what are we going to do about global fishing that continues to obliterate the vertebrates from the ocean, from the water surface to the seafloor? Much of this fishing is illegal and uncontrollable. Spain is one of the major players of this illegal fishing, so is China and so many other countries.
Yes. Well, I would invite the person who posed the question to read my paper, because there we actually report the global status of fisheries, and we show that the number of fisheries that are managed sustainably is actually growing and increasing. So the perception that fisheries reach a peak around, in terms of catches, reach a peak around 1990, and then has been slowly declining since, but now it's starting to go up. But also because many nations have adopted and embraced sustainable fishing and scientifically determined quotas. So the number of fish stocks that are fished sustainably has increased, and is actually now a large proportion of them. And I think there's some references to China and Spain and so on. In Spain, for instance, I would say the contribution to illegal fishing is really very small. So I don't know what that statement is coming from, but I can see also in Spain some major achievements in rebuilding the stock of bluefin tuna that comes into the Mediterranean every year, and also the stock of anchovy and other fishes that were overfished, and now they're actually thriving, and the population and stocks are in very good condition. So we actually forecast that if we are wise, and of course we need to manage illegal fishing and unreported fishing as well, but if we are wise and move towards reducing overfishing in the same vein that is happening, we can actually rebuild the stocks of fish within 20 years. But I also would like to indicate that we discovered in 2014 and published a paper in Nature Communications where we discovered the largest fish stock in the world, which is the mesopelagic fish, which biomass alone is 30 times larger than the biomass of all other fish combined. And this fish stock is untouched because it cannot be fished, because these animals are able to escape any device that humans have been able to invent. So, we have a large, pristine stock of fish also in the ocean. So the capacity of fish to contribute to moving carbon is not as impaired as implied in the question. But details of the current situation and the projections are found in my paper if they want to learn more. So I think that we can dwell on the negatives and ignore the many positive developments that are happening, but fisheries actually are improving rather than going wrong globally.
Thank you, Professor Carlos. We have only a few minutes left, so probably let's address the last two questions. We have one question from Professor Hussein Hatate. Current CO2 emission rate is around 35 gigatons per year. What is the remove rate that can be practically achieved per year by nature-based solutions? Yeah,
so the nature-based solutions, I think so these emissions are in carbon dioxide values, and most of the values have been given were in carbon units. So there's a little bit of things about units if you need to consider the numbers, but nature-based solutions are growing. So in fact, if you search nature-based solutions in the literature, the first paper is actually from 2016, and is really an offspring from the Paris Agreement. So the focus on nature-based solutions, term nature-based solutions, is relatively new, but it's rapidly growing. So right now, the delivery of nature-based solutions is relatively small. So the delivery of today of nature-based solutions is probably of the order of 0.2 gigaton carbon, which will be about 0.6 gigaton carbon. So it's very low relative to what is needed, but it is rapidly growing and rapidly ramping up. And not only because we know more about these solutions, but because there are global funds and global programs to deliver them. And in fact, if we back calculate, there's been already significant nature-based solutions deployed, because in many areas like Europe, the forests have actually been regrowing rather than declining because of a contraction of agriculture. So it's been already not driven by climate change, but that has happened in Europe and other areas. And also based on concerns on coastal protection, there's been very large mangrove afforestation programs across the Indian Ocean and Asia. So those have already delivered many thousands of square kilometers of restored mangroves that also contribute significantly. So we calculate that the growth rate of nature-based solutions will be quite significant, and probably by 2030, the removal rate might be about 10 to 20% of that required to meet that 30-something gigaton of carbon dioxide.
Thank you for your answer. It would be great if we can achieve this share. Truly amazing. And the last question is from Alexander Petrovich. Thank you for the interesting and inspiring talk. However, to say burning hydrocarbons are not the problem and we just have to restore nature and capture the CO2 is like modern medicine, fighting symptoms but not the cause. Of course, it is an important part of the game, but it is just a part. For instance, something that is missing in your calculation is the enormous amount of methane that will be released in the near future. It is already going on within the polar regions related to the thawing of the permafrost. What is your comment on that?
Yeah, so first I didn't say that burning hydrocarbons are not the problem. I said carbon is not the enemy. And I said, what we need to do is to decarbonize the atmosphere, not to decarbonize the economy. And of course, decarbonizing the atmosphere requires that we do not emit greenhouse gases to the atmosphere. So just to precise that, that's not exactly what I said. So I think I don't know if this is being recorded, but then you can review what I said. And this is not something that I said, so I shouldn't be quoted on things that I didn't say. And on the methane hydrates, that's actually something that I work on. So I have a 10% appointment. So I was allowed by KAUST to continue my work on the Arctic Research Center in Aarhus University in Denmark. So I have done many cruises in the Arctic, and I've been measuring methane in the Arctic a lot. And right now we have a paper in review on a global budget of methane. And in that paper, actually, we have no reliable contribution from melting of methane hydrates yet. So the potential is huge because the reservoir of methane hydrates in the Arctic, in the continental shelves particularly, is very large. But the emissions that are happening, and I've been recording myself, of the shelf of Norway and also Russia, is actually not attributable to warming, but it's attributable to geological processes in this area. But there is a risk that some of these methane hydrates can be destabilized with warming and emitted, and that again can trigger a very dangerous climate change. So that's something that needs to be looked into detail. But also for methane, we are now working with an ocean-based solution, not for the Arctic, but about 40% of emissions from the agricultural sector come from greenhouse gases are emissions of methane from livestock. So about 3 years ago, then through work that colleagues of mine have been doing, it was found that if you feed red macroalgae to cattle and sheep and so on, you can actually shut down the methanogenesis and reduce methane production by ruminants by about 60 to 90%. So this year, the first whole farm experiment was conducted by the CSIRO in Australia, and they actually documented a 90% reduction in methane from cattle that were fed red seaweed, and also an improvement in the health condition of the animal and the quality of the products. So we can do something about methane, but not quite in the Arctic, where things are going really wrong. And I'm publishing regularly about the Arctic as well.
Thank you, Professor Carlos. We still have some questions not answered, but probably we will communicate later with you to receive an answer for them. Unfortunately, we do not have much time left. Just from my side, a few minutes of closing remarks. Certainly, climate change is an issue for all of us. But we as humans, we sometimes think that new technologies and innovation will solve our problems and allowing us to continue our business as usual lifestyles. But this is not totally correct. It's not enough. It is a misleading assumption because we cannot solve climate change without introducing profound changes in our style of life and also, of course, restoring nature at an unprecedented scale, especially, as you said, like oceans and forests, because it is keeping our planet cool. And today we learned truly some of the amazing examples on how carbon can be managed in order to achieve climate goals, but also providing benefits for natural habitats and for people. I hope you enjoyed our seminar today. Please follow us for the, okay.
Yeah, I just wanted to comment that in 45 minutes, I'm having a meeting with a Russian top model, which is called Ria Serebriakova. So Ria Serebriakova is a Russian top model that is based in New York, but she's also an environmental activist. And you can actually Google her, and she's been campaigning against plastics. So we're going to have a collaboration around how the fashion industry can change the materials they use and help resolve sustainability issues, including climate change. So I think we need to be given opportunities to buy products that are consistent with our values, and that requires generating new products and new materials that we can use in our daily lives. So it's not all about technology, but there are many solutions, and everybody can be part of the solution. Yeah.
Well, thank you very much. I wish you good luck for your meeting.
Thank you.
Thank you all for joining us today. Please check our social media for more interesting webinars and events coming. Thank you all. Enjoy your evening.
Thank you.